Yes, today I will be dealing with the derivative of logarithmic function. Get me? Though it is difficult, very hard, but as you are watching this video, I will make everything easy. Then you will enjoy it. Don't forget it is still vital tutorial. Please don't don't forget to subscribe. Now let's go. No panic, no panic, no panic at all. Your solution is right here. Now I always told you, I said the question being given to you, let's assume the question is in this form. You are told to find the derivative of y is equals to log of x base a to show using what? First principle. I always told you make this one your what? Equation of by 1. Then the next thing you need to know is that you add your change in y to y, which is y plus change in y, which is equals to what? Log of what? S plus change in s. So you can put your bracket base a, make this one your what? Equation 2. Now you can now subtract equation 2 from equation 1. You can now subtract equation 2 from equation 1. Now let's go. It will be what? Y plus change in y minus y. To y with what? Cancel y. Then we'll be left with what? Change in y equals to log what? Log s plus change in s base a minus log s base a. Now you know in our logarithm whenever we have log a base s minus log b base s is the same thing as what? Log what? A all over what? B base what? S. So I'll be applying this rule here. It's nothing but change in y is equals to what? Log of s plus what? Change in s over what? S everything to the base of what? A. Now I want to split this. Change in y is equals to log of what? S all over what? S plus what? Change in s over what? S everything to the base of what? A. Don't forget this thing here is not hard. It's just s plus y over what? Z. It's the same thing as what? X all over what? Z plus what? Y over what? Z. So I hope you are following. Now change in y is equals to this. So here you agree with me that s will cancel as s. Then we'll be left with what? 1. So it will be equals to change in y will be equals to log of what? 1 plus change in s over what? Over s base what? Base a. Now the next thing is we can now what? Divide through by what? Change in s. We will divide through by change in s. It will be what? Change in y over change in s is equals to log of what? 1 plus change in s over s base what? Base a everything over what? Change in s. Now I want to shorten this. I can shorten this to what? Change in y over change in s will be equals to what? 1 all over what? Change in s multiplied by what? Log of 1 plus what? Change in s over what? S base what? A. It's still the same thing. 1 multiplied by everything here will give us everything here over what? Change in s. Now the next thing now is that you will work with a mindset that how can you have the inverse of this right here? The inverse of change in s over s. It may be difficult for you, but as you are watching this video, I bet you it is very easy. Now you just use a trick. You can just introduce, if I say I should introduce change in s over change in s, what I will have here is nothing but change in s times 1 will give us change in s. While change in s times change in s will give us change in s squared. I will not have anything as that. Now what I can do now, if I introduce s all over s, yes, I'm going to have something. S all over s is equals to what? S times s will be 1, while s times this one will give us s change in s, but I'll still have something meaningful. So I will introduce that s over s multiplied by 1 all over change in s multiplied by what? Log, or I should say log of 1 plus change in s over s over what? Or to what? Base a. Now look at this. For me to, I can have the inverse of change in s over s here by just bringing what? S back here. Now for me to have back this equation, I can have it back because s all over s is just what? There is nothing but what? 1. And 1 multiplied by everything here is equal to what? Everything back here. So we have not changed anything, because you may doubt that how does this s all over s affect this equation. No, it doesn't affect it, because s all over s is what? 1. So change in y over change in s is equal to, if I bring s back here, what will remain here is just 1. So it will be 1 all over s multiplied by what? S all over what? Change in s log of what? 1 plus change in s over what? S base what? A. Now there's a rule in indices that says that n log of a to s is equals to log of a raised to power of what? N base what? S. Now I'm bringing everything right here back to this what? Part. So is equals to change in s, change in s, change in s, change in y over change in s is equals to 1 all over s, 1 all over s log 1 plus change in s over s, everything over s over what? Change in s. I hope you are what? Following, and I hope you are enjoying what? The class. So change in y over change in s is equal to 1 all over s log into what? 1 all over, sorry, I have to put what? My base a, sorry, I have to put my base a, 1 plus change in s over s raised to power of what? S all over change in s. Now what is the next step? What do you think we can what? Do? The next step here, if some of you may be thinking that let us introduce what? Our what? Limit. Yes, you are very, very correct. Let's introduce our limit. Let's introduce our limit. Limit as change in s approaching 0 of what? Change in y over change in s, it will be equals to the limit as change in s approaching 0 of all this function here, 1 over s log of what? 1 plus change in s over s base a, everything raised to the power of what? S all over what? Change in s. Then you can what? Close your bracket. So the limit, I told you earlier, I've said it in my previous video, I said the limit as change in s approaching 0 of change in y over change in s is nothing but what? The y over the s. I love this. The y over the what? S. So I have to take the what? The limit part by part, because it is obvious that the lim as change in s into a multiplied by b is equals to lim as change in s approaching 0 of a multiplied by what? The lim as change in s approaching 0 of what? Of b. So it is obvious, it exists. So I'll just take the lim as change in s approaching to 0 of what? 1 over s, and the lim as change in s approaching 0 of log of what? This. So I want to clean this part so that we have enough space. So change in y, I told you earlier that this is nothing but what? The y the s, which is equals to the lim, follow the path, the lim as change in s approaching 0 of 1 all over s multiplied by what? Lim as what? Change in s approaching 0 of log of 1 plus change in s all over s raised to the power of s over what? Change in s base what? Base a. Now if you look at this, the limit as change in s approaching 0 of 1 all over s, you will agree with me that it is nothing but what? 1 all over s, because change in s here has nothing to do with what? 1 all over s. It is just like limit as change in s as change in s approaches 0 of what? 5. It is nothing but what? 5. Because here you will be substituting for change in s, you will be substituting 0 for change in s wherever you see change in s. And if you look if you see that there is no change in s in what? The equation, the part you want to take, so you just leave the part will what? Remain the same. So here the y over the s is equals to what? 1 all over what? S. The limit as change in s approaches of 1 over s what? 1 all over s. So we left with what? The limit we left with the limit as change in s approaching 0 of log of 1 plus what? Change in s all over s to base a raised to the power of what? S all over what? Change in s. S all over what? Change in s. So now I know that this part is nothing but what? It's nothing but e. But how do we arrive at sorry let me bring out this log. Then I'll take the limit, or let me leave it. But I want to show you that the limit as change in s approaches 0 of log of this. Let me bring it out so that it will make more sense. To do what? The y over the s is equals to 1 all over s dot the log to base a of the limit as change in s approaching 0 of what? Of 1 plus change in s over s raised to the power of what? S all over what? Change in s to what? To base 8. So I am to show you that the limit as change in s approaches 0 of 1 plus change in s over s raised to the power of s all over change in s is nothing but what? E. That is why we have our divide the s to be equals to 1 all over s log e base what? A. But how do we arrive at e? You don't know. Now I want to show you. Please follow me patiently and you will understand the whole thing. No panic here, right? No panic here at all. Your solution is right here. Let me clean this part up. Please don't forget to subscribe. Don't forget to subscribe, comment, and like, and share the links to your colleagues. So let's go. Now we are having the y over the s to be equals to 1 all over s log base a into what? The limit as change in s approaching 0 of what? 1 plus change in s over s raised to the power of what? S all over what? Change in s. Close your bracket. Now I want to solve only this part. I'm bringing out only this part. So let me solve only that part. To be limit as change in s approaching what? 0 of 1 plus change in s over s raised to the power of s all over what? Change in s. Now I will say the next thing to do here is just I will say let n equals to s all over change in s, or let p equals to s all over change in s. But I love working with what? N. I love letter n. I love working with what? N. So I will say let n equals to what? Let n equals to x all over what? Change in s. If n is equal to s all over change in s, then for me to have change in s over s, it means it's just the inverse of n. So 1 all over n is equals to what? Change in s over what? X. So now the next thing is as change in s approaching 0, n will be approaching what? Infinity, because I'm no longer working with what? Change in s, because I already said let S all over change in S will be equals to what? N. So n will be approaching what? Infinity. I'm not good in drawing, but please manage this as infinity. So now let me come back to this. The limit as change in S approaching 0 of 1 plus change in S over what? S to the power of what? S all over what? Change in S will be equals to the limit as n. There's nothing like change in S again now. There's nothing like change in S. Let me put this here as change in S. As change in S approaching 0, the n is approaching what? Infinity. So to be what? N approaching what? Infinity. N approaching, I'm not good at drawing. So infinity. So just manage it as my infinity. So to be what? 1 plus 1 all over n, because change in S over S is nothing but what? 1 all over what? N. So everything to the power of what? N. Because n is equals to change in S over what? X. Light is raining here, please. I don't know how you feel it in your place. So just please bear with us. So here limit as what? N is approaching what? Infinity. So here is nothing but what? Is nothing but what? Binomial expansion. So I'll be introducing binomial expansion. So it will be here we have limit as n approaching what? Approaching infinity will be equals to, as n approaching infinity, of 1 plus 1 all over n to the power of n will be equals to, now I want to expand this. I want to do the expansion going back to what? Our binomial expansion. Binomial expansion. I would like to do a little introduction before I go back to that, so that you understand it properly, without any cramming. Properly. This is vital tutorial where mathematics will be injected into your memory, will be injected into your system, will be injected into your bone marrow. That is what? Understanding. So that can only be achieved by you understanding the concept. Here, when we have S plus what? A. When we have S plus A, or let me say A plus S, anyhow. Let me say A plus S. It will be equals to A to the power of n. A plus S to the power of n is nothing but what? Binomial what? Expansion. And this is how we go about it. It will be what? A to the power of n. Lord, I would have explained this better, much more better. But if my video is still coming on what? Binomial expansion as a topic on its what? Own. So here, just manage with me. Let me just show you the formula. A to the power of n plus what? Combination of n to what? 1. Combination of n to 1. Don't forget, your A will be what? Decreasing. While your A will be what? Increasing. Your A will be decreasing with the power of 1. While your S will be increasing with what? Power of what? 1. So it will be what? N minus 1. While your will be A minus A to the power of n minus 1 and S to the power of what? 1 plus combination, let me put it here, plus combination of n to what? 2, A to the power of what? N minus 2, S to the power of what? 2, plus plus. If you get to a time that the combination itself will attain what? Equilibrium. That is equilibrium. That is if your n will be equal to n here, and your n will be equal to n here, and your s will be also what? Equal to s. That is S will attain the equilibrium of A, and A will attain the equilibrium of what? S, and combination will be in what? N to n. So it will be what? C raised to the power of n into what? N to n. A raised to the power of n minus n, and S raised to the power of what? N. Yes. So yeah, I'll bring back that same idea here. I don't want you to say I don't understand. That's why bring the what explanation. So let's go back here. To expand this, it is nothing but what 1 raised to power what n. Follow that combination of what combination of n to what 1, and your don't forget your 1 will be decreasing by what 1 raised to power what n minus 1 into what 1 all over 1 plus what combination of what n into what 2 to 1 raised to power what n minus what 2 into what 1 all over what n everything raised to power 2 plus dot 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 plus combination of what n to n and 1 raised to power what n minus 1 n minus n into what 1 all over what n raised to power what n. Yes, that is what binomial expansion. Yes, so I would like to do the solving of this to show you the combination of what rule of this, combination of rule of this, combination of rule of what this. So sorry. So don't forget that the combination of n to 1 is nothing. You see your what normal combination formula is still equals to what n what factorial over n minus 1 factorial into what 1 factorial, which is equals to n into what n minus 1 factorial, everything over what n minus 1 factorial over what 1 factorial. Don't forget that your n minus 1 factorial will neutralize n minus 1 factorial. Then will be left with nothing but what n over what 1 factorial. Same thing, combination n into 2 will be equals to what n factorial over what n minus 2 factorial over what 2 factorial, which is nothing but what it is nothing but n minus 1 n into n minus 1 into what n minus 2 factorial, everything over what n minus 2 factorial 2 factorial. Don't forget your n minus 2 factorial will neutralize n minus 2 factorial. Then we'll be left with what? We'll be left with n into n minus 1 over what 2 factorial. That is that. Now here will be the remaining part is what n into n. Just follow the same path. It's still the same thing. N into n will be equals to what n factorial over what n minus n factorial n factorial. N factorial over n minus n factorial n factorial, which is equals to, don't forget that n factorial will neutralize n factorial. Then we'll be left with what 1 here. Don't forget this one will be n minus n, which is 0. So we'll be left with what 1 all over 0 factorial. Don't forget your 0 factorial is nothing but what 1, which will be equal to 1 all over 1, which is equal to 1. So I'll substitute combination of n to 1. I'll substitute n all over 1 factorial for combination of n to 1, and I'll substitute this for this. I'll substitute this for this. Let's go. 1 raised to the power of n plus combination of n to 1 is nothing but what n all over what 1 factorial. 1 factorial raised to the power of what n minus 1 into what 1 all over n raised to the power of what 1, which is still what 1, which is still 1 all over n plus combination of n into 2 is nothing but what is nothing but n into n minus 1 all over 2 factorial. N into n minus 1 all over 2 factorial into what 1 all over n all square plus dot dot plus, don't forget that n minus n is nothing but what 0, and 1 to the power of 0 is what nothing but 1. So 1 multiplied by this and this will give us this and this. And don't forget that the combination of n to n is nothing but 1. So this one is 1, this one is 1. 1 times 1 times this is nothing but 1 all over what n to the power of what n. I hope you are following, and I hope you are enjoying the what class. So what will be our next step? Again, let me quickly tell you this. Let me quickly introduce you to what 1. I'm cleaning all this part. I'm cleaning all this part. I'm cleaning up that part. So now 1 raised to the power of n. 1 raised to the power of any number is still what? 1. Let's try it. 1 raised to the power of 2 is equal to 1. You still don't believe? Okay, let's try the negative part. 1 raised to the power of minus 20 is nothing but what? Don't forget, 1 raised to the power of minus 20. 1 raised to the power of minus 20. Come back to your indices. S raised to the power of minus 1 is equal to what? 1 all over s. So 1 raised to the power of minus 20 is nothing but what? 1 all over what? 1 raised to the power of what? 20. Which is equal to what? 1 raised to the power of 20 is what? 1 times 1 times 1 times 1 times 1 to 20. Which is equal to what? 1. So which will be what? 1 all over 1. And 1 over 1 is still what? 1. You now believe? Yes. So now 1 raised to the power of n is nothing but what? 1. Plus n, don't forget this one will be what? 1. This one will be 1. This one will be 1. I'm sorry, I did not put 1 into n minus 2. Let me quickly do that so I can get the better understanding. Sorry. So it will be what? 1 raised to the power of what? N minus 2 into what? 1 all over n raised to the power of just 2. So this one is what? 1. This one is what? 1. So I'll be left with what? N over what? 1 factorial. N over 1 factorial into what? 1 all over n. 1 all over n plus what? N into n minus 1 all over what? 2 factorial into what? 1 all over n square plus dot 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 plus 1 all over n. 1 all over n to the power of what? N. Yes. Yes. So before I proceed again, I would like to show you the Maclaurin what? Principle. Maclaurin principle. Maclaurin principle. Maclaurin principle. Maclaurin principle is just all about what? Exponential is equals to what? 1 raised to the power of 0 over 0 what? Factorial. Why is this on 1? Because here the power of e here is just 1. So we are starting with 1. Then we are starting the power is starting what? From 0 over what? 0 factorial. This all what Maclaurin is just trying to say. Plus 1 raised to the power of 1 over 1 factorial plus 1 raised to the power of 2 over what? 2 factorial plus dot 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 plus to what? Infinity, like that. So let's go there. It's I just put that infinity there, so it still continues. It's a continuous what? It's a continuous series. So let's go. Let's come back here. So 1 plus what? N into what? Combination of 1. Don't forget that this one will be n all over 1 factorial into what? 1 all over n plus n into what? N minus 1. So let's go there. This one is nothing but don't forget that we are still dealing with this to be what? The limit as what? N approaching to what? Infinity. As n approaches infinity of 1 plus what? 1 all over n. Everything raised to the power of n. Everything raised to the power of n is nothing but 1. It's nothing but 1. Don't forget that this n, we neutralize this n that is here. Then we'll be left with what? 1 all over 1 factorial plus 1 all over what? 1 factorial plus 1 all over 1 factorial. Here, I would like to expand this outside. I want to avoid the clumsiness so you understand it better. Let's solve this here. If we have n into n minus 1 all over what? 2 factorial. Everything here. Anytime, according to your indices, anytime you have x all over y raised to the power of 2 is the same thing as x raised to the power of 2 over what? Y raised to the power of 2. So let's apply that here now. It's nothing but what? 1 raised to the power of what? 2. 1 raised to the power of 2 is still what? 1. It's still what? 1. And x raised to the power of what? 2. So here, as if you look at this critically, you will observe that n becomes what? 1n here. Then we'll be left with what? N. So we'll be left with this will be equals to n minus 1 all over what? 2 factorial into what? 1 all over what? N. into 1 all over n. Now I can bring out 1 all over n, 1 all over 2 factorial. If I bring it out, 1 all over what? 2 factorial, and I can say n minus 1 multiplied by this. N minus 1 multiplied by this is nothing but what? N minus what? 1 over what? N over n. Sorry, not factorial this time around. So here I can split this. If I split this, I'll be left with what? 1 all over 2 factorial into what? N all over n minus 1 all over what? N. Don't forget that n all over n is nothing but what? 1. So it will be equal to 1 all over 2 factorial into what? 1 minus what? 1 all over what? N. So everything here is nothing but what? 1 all over 2 factorial into what? 1 minus what? 1 all over n. So I'm going to bring that here right now. Plus, so I can clean this part off. It's nothing but it's nothing but 1 all over 2 factorial. 1 all over 2 factorial into 1 minus what? 1 all over what? N. 1 all over n plus plus, don't forget 1 to the power of n is what? Is still 1. 1 to the power of n is still what? 1 over 1. Everything to the power of what? N to the power of n is still what? N to the power of what? N. N to the power of n. So here, the limit as n approaching what? Infinity of 1 plus 1 all over n to the power of n is nothing but what? 1 plus 1 all over 1 factorial plus 1 all over 2 factorial into 1 minus 1 all over n plus plus 1 all over what? N to the power of what? N. Now the next thing here is just to what? Is just to take the limit. And compare this to this. Maybe we have the same what? Similar answer. So let me rub up what? This part. Alright, so this one, if I take the limit, there is no need taking the limit anyhow again. This one, if I what remains here is just to take the limit. It will be equal to, if you are taking the limit as n approaching 0, this one doesn't have n. So the answer will still be what? 1 plus 1 all over what? Infinity. 1 all over 1 factorial plus 1 all over what? 2 factorial. This n approaching infinity, it means that anywhere I see n, I will just put what? Infinity. Let's assume that I put infinity here. It means 1 all over infinity, which is equal to what? 0. I told you earlier, I said 1 all over infinity is what? 0. So if it is 1 all over infinity, 0, 1 minus 0 is what? 1. And 1 multiplied by 1 all over 2 factorial is 1 all over 2 factorial plus plus what? 1 plus into a bracket of 1 infinity raised to the power of infinity. Infinity raised to the power of infinity is nothing but what? Infinity raised to the power of infinity is nothing but what? 0. So 1 all over 0 is what? 0. And that part is what? Done. So if you compare this part, if you compare 1 plus 1 all over 1 factorial plus 1 all over 2 factorial, you will see that you will get what is here. Here, what is happening here is what? 1 to the power 0 is what? 1. And 0 factorial is what? 0 factorial is nothing but what? 1. 1 all over 1 is what? 1. And here we have 1 all over what? 1 factorial. And here we have 1 all over what? 2 factorial. It then means that the limit, this limit, everything here is equal to what? 0. Is equal to what? E. Your E. So now let's go back to the formula now. Divide the s is nothing but what? 1 all over s. 1 all over s log of what? E base what? Base A. Log of E base A. Did I deserve a round of applause? So that's everything that is what? There. So your E is nothing but what? The limit as what? 1 plus 1 all over what? N. Everything is the power of n, and as n approaching infinity, everything is what? E. So I've shown you that. Please, this is vital tutorial. Don't forget to like and comment. Thanks.